6 million years ago, Earth was a pretty different place. It was covered in huge forests. Oceans were brimming with life, mainly ancient marine animals. And on land, there were mighty dinosaurs. The towering T-Rex and swift Velociraptor were only two of those magnificent creatures who survived and lived well for millions of years. Then something quite extraordinary happened. From the geological perspective, it folded all within a twinkle of an eye, thus releasing one of Earth's greatest extinctions ever witnessed in history. Let's discuss this interesting mystery. How did the dinosaurs become extinct? You must have heard that a huge asteroid was responsible for their disappearance, but it is rather more complicated than that. The story is complex. Many theories, scientific debate, and new research to find the pieces of that puzzle. Let's begin by examining each theory: asteroid impacts, eruptions, and volcanic. How scientists piece them together to solve this old mystery. The most popularly accepted theory regarding the cause of extinction of dinosaurs is the impact hypothesis of asteroids. According to this, it was considered that a gigantic asteroid collided with Earth, causing extreme changes in the environment. Scientists discovered the Chicxulub crater that lies on the Yucatan Peninsula in Mexico. It has 180 kilometers in diameter. This crater is very well confirmed to be due to an asteroid of about 10 kilometers in diameter. The energy would be comparable to billions of atomic bombs, causes shockwaves and tsunamis, and can vaporize everything around the point of impact. This created what was thought to have an impact winter, for enough material ejected into space may block sunlight. Photosynthesis for the plants and all food chains shut down at a rate that temperatures throughout the world plummeted sharply. Plants and the phytoplankton that exist within the ocean starved with no sunlight. Then that starved the herbivores, then the carnivores, resulting in wholesale die-off of species. Geologists found that there was a distinct layer of iridium-rich clay throughout the different parts of the world and is dated with an age of 66 million years. Iridium is highly rare on Earth's crust but is abundant in asteroids. Hence, this clay rich in iridium is an excellent supporting evidence for the impact hypothesis. The layer, which has been termed the KPG boundary, is found in rocks all over the whole world and remains one of the most compelling pieces of evidence for the asteroid impact theory. Although an excellent cause of the extinction can be associated with the asteroid, scientists explain that volcanic activities may also have been one major cause alone or together with the effect of the impact of the asteroid. This would be during the eruptions occurring in what is today India, where volcanically enormous eruptions occurred from the Deccan Traps. Such eruptions would persist for tens of thousands of years, including emissions of large-scale volumes of lava, carbon dioxide, and sulfur dioxide into the atmosphere. In the presence of these gases, a very well-established greenhouse effect might lead to heating up the climatic conditions on Earth with acidification of the ocean that puts a stress on world's ecosystems. Other researchers have provided the double disaster hypothesis, suggesting that it is the one where both volcanic activity and the impact of the asteroid triggered the extinction event. Volcanic activity in this case can be considered long-term but has an effect that weakens the population of the dinosaurs to become prey in cases where the asteroids cause impacts. This will mean few species are in a position to survive a condition characterized by an unstable environment. Fossil records show progressive change in species diversity before an impact and, therefore, these ecosystems were stressed even before such an impact. In addition, large-scale eruptions did take place during the Deccan Trap cycle and might quite well have contributed to the deteriorating climate. Although the theories that implicate an asteroid and volcanoes are the most probable, there are other ideas or factors which several scientists have proposed to account for the extinction of the dinosaurs. Natural climate variability such as fluctuations in sea level and temperature would influence habitats, especially those species that favor the coastlines or marine habitats, change vegetation, and food items. This probably is not a contributing factor to the weakening. However, it probably makes a weakened ecosystem prone to a disaster. Some paleontologists think that the populations of some dinosaurs were beginning to decline for certain ecological reasons even before the impact. Fossil record reveals that in some groups, diversity might have started falling because of competition with other species, diseases, or changes in the environment. It was perhaps the coup de grace rather than being the cause of death given by the asteroid impact or eruptions of supervolcanoes. This KPG event was not an exception by marine life and plants. Perhaps there are extinction pulses occurring over a few million years, rather than a single event, and perhaps biodiversity had a more gradual shift. It had also closed the Mesozoic era and marked the beginning of the Cenozoic era, later known as the Age of Mammals. With the dinosaurs out of sight, the mammals began to grow and develop into the varied forms that we see today, small, inconsequential at this point, and all but forgotten. This enabled mammals to occupy newly vacated ecological niches and to evolve into various forms such as rodents, large herbivores, and predators. It is during this adaptive radiation that primates evolved to man. Meanwhile, other organisms had to evolve to survive in a world without large herbivorous dinosaurs. This opened up the opportunity for flowering plants to dominate and eventually create the ecosystems that mammals would rely on, making forests and grasslands dominant and allowing mammals to radiate and diversify into forests as well as grasslands. Of course, it demands an interdisciplinary approach: geology, paleontology, biology, and chemistry, because knowing the climatic background of Earth, atmospheric composition, and even key events like asteroid impacts and supervolcanoes eruptions helps researchers in interpreting the death of dinosaurs. Fossil records can also help determine which species fell and how, under extinction pressure, ecosystems evolved. Scientists use methods like isotope analysis, radiometric dating, and computer simulation to create high-resolution models of events that occurred centuries ago. For example, isotopic analysis of iridium layers may indicate an impact by asteroids, while computer simulation of volcanoes may show how gases may affect climate. Even after all these years of research, the cause of the extinction of the dinosaurs remains a debatable issue in today's world. Every new discovery brings more questions